Welcome to this presentation about facilitating authoring of augmented reality for indoor planning and the ATLANTIS project. My name is Werner from Ionium Research, and I'll present this work together with my colleagues Robert Weimer, Julia Parinova, Richard Whitehand, and Nick Zioulis. So what are we going to do in this presentation? We first talk a bit about the ATLANTIS project and the goals and the approach we are taking. Then we look into the initial user research and the insights we gained from there. And then we talk about the technical challenges and give some outlook. So ATLANTIS is an acronym for Authoring Tool for Indoor Augmented and Diminished Reality Experiences. It's an innovation project in the European Union's H2020 framework program. We started in July this year, and the project is expected to finish in February 2022. There are 4 partners involved: Ionium Research, which is a research institution in Austria, is project coordinator and is also responsible for the research in semantic scene analysis and layout as automation. THIRS, which is a Greek R&D institution doing the technical coordination and research in panoramic scene understanding. RUML, which is an Austrian SME working on the AR application and also responsible for the integration. And they are also the main drivers behind the use cases, as the results will flow into their products and services. And Usability Partners, a Swedish SME with experience in user experience design and also performing the evaluation of the prototypes we develop in the project. So the vision of the project is to facilitate communication with customers for indoor planning. Indoor planning, whether it's renovation, refurbishing a room, buying new furniture, it's a communication process between salespersons, designers, and the customers who want to change their home, their office, their shops, spaces. And it requires conveying ideas about how it might look like and what requirements are that need to be fulfilled. And the goal is to enable non-expert users to communicate these ideas by being the author of an AR and DR experience. So we want to include both AR and DR here, because changing always means getting rid of objects that are actually in the real world and replacing them with something else. In order to facilitate this process, we want to start with capturing from a panorama and then have a number of AI-based tools for scene understanding and for layouting to facilitate this process as much as possible and make it feasible for non-expert users to actually create such scenes. We are going to implement that as a user-centric approach from the start, as you will also see in the results we present later. So we keep permanent dialogue with the users from the start and developing this solution together. We are mainly now targeting consumers and professionals in interior design and furniture retail. Of course, these technologies might be useful for other application areas as well, but those are the domains we are addressing in the initial stage. And we expect that the results of the project will actually democratize AR and DR, making it possible for everyone to use these technologies to communicate their ideas. And in the specific usage domains, of course, this may translate into cost savings because you avoid redoing things, and also into increasing customer satisfaction because they were able to see very early on in the process what the final result will be, and could also communicate back their ideas. So the workflow is starting from capturing panorama using consumer-grade technologies, so making it very simple to start. Then this goes into AI-based analysis services, doing things like layout analysis of the room, as you see on the top, so identifying where the floor is, where the walls are, so that we get an idea of what this room looks like, and also segmenting objects that are already in the room, because we might want to remove them or change them later on. With this, we go into authoring. So we already have a very good idea of what is in the room. And let's say that the user wants to get rid of that Christmas tree there in the left corner. Maybe sometime after Christmas you want to do that. We segmented it. Actually, we labeled this as a potted plant, which is not exactly the same thing, but good enough. And the user is able to click that region. And as we know where the tree was, we can inpaint that area. And the user can select another object from the catalog to insert there. And then preview these things as an AR view, or also as a 3D view with the 360 image we captured as a background if they are off-site. So the approach is that we have a simple capture process, not requiring to basically draw the room, but starting from a panorama. We have a set of services for scene understanding that will know where objects are that can be selected to be diminished, but also where there is space to insert new objects to make sure they don't float in midair when we insert them. And so we have backend services that prepare the scene for efficient user interactions. So that's a lot of things can be done with a single click and not require drawing things and cutting out objects in the scene. And then you can view that scene with the Captured 360 scene if you're not on site. So if you're, for example, in the shop talking to the salesperson, but you can also view it as an AR experience, and that's probably the most valuable thing to do when you are in the room with the objects that were added or were diminished, or both of it, so replacing an existing object with a new one. And now I'll hand over to Richard, who will tell us about the initial user research we did and the insights we gained from that.
Thanks, Werner. I'm going to be talking a little bit about how we've involved users so far in the project and some of the things that we have planned. As Werner already mentioned, it's a very user-centric project, and Usability Partners is the partner in the project that's responsible for conducting the user research and involving users throughout the design process. And we're doing this in a very iterative manner. So users will be involved in a whole series of activities throughout the project to give continuous feedback to the project and to actually steer the process, to steer the decisions that are made around the interface design in particular. And talking about users, it's very important that I just mentioned the target audience that we have and that we're working with. On the professional side of things, we've got those working with interior design, such as salespersons and interior designers at furniture retailers in particular. We've also got salespersons and project managers or key account managers working at different kinds of specialist equipment suppliers. So, for example, those that supply to the healthcare sector. And finally, we've got independent interior designers. It can be interior design firms or those working at architecture firms, for example. On the consumer side of things, those actually working to improve their home. We've got those who are doing larger scale renovation, maybe completely renovating their home, through to those who are maybe just looking to buy a few items of furniture to complement furniture that they already have in a particular room in their home. And talking of the user involvement, we're going to be following, or are following, a user-centered design process in accordance with ISO 9241. And really, throughout the project, doing different kinds of activities. At the beginning, we've been focusing a lot on trying to understand our target users, understand their needs, different activities there, which I'm going to touch on in a moment. But then as we work with different design solutions, we're going to be involving them in different kinds of workshops and different types of testing activities as well, to test out different prototypes through from very simple wireframe prototypes to more interactive designs as we go through the project. And this is an iterative process, as this slide tries to indicate here. The whole process is a very iterative one, but also particularly this phase between evaluation and design is one where there's going to be a lot of iteration of testing with users. And I'm going to talk a little bit about what we've got out so far from some user surveys that we've run, a review of different competitor products in the area, and in particular a series of 30 or so in-depth user interviews that we've conducted with different members of the target audience. So some highlights from those activities then. Many of the target professional users that we've talked to are, how to put it, rather old school. If you think about those working in furniture retail shops, they're perhaps more comfortable with simple sketches in many cases than the idea of AR or VR technology. And this puts them a little bit outside their comfort zone, and is going to be an important factor to consider in making sure we've got a simple user interface. Another important consideration is that existing planning tools involve quite an initial investment of time and energy in measuring up rooms, setting out different things in the room, and people today, certainly on the consumer side, tend to only use them for bigger projects. So the idea with indoor scene reconstruction, as Werner's already mentioned, should facilitate the broader use of such tools through simplifying this process. The upfront investment in time, we're hoping, should be a lot less. Another consideration is that authoring tasks need to be possible in the AR or diminished reality room view. Users quite clearly expect, if they're going to have a view like that, where they can see new furniture in place, they want to interact in that view as well, and not constantly switch between the AR view and some other editing view, at least for simple changes to furniture. The solution also needs to be one where it allows a lot of, or eases, professional consumer collaboration. So consumers want to interact and make changes to the designs that are actually created by professionals. So you can see that the underlying need for some sort of collaboration on these designs. And the AR or DR view is not enough in itself. This AR DR view may be great for simple changes and for users, as illustrated here, to hold up their device to see what the room would look like with furniture changed or added. But they don't want to operate in this view all the time. They want to be able to relax, have the mobile on their lap, and then on occasions hold it up to see maybe what it would look like. So they also need a VR view, as it were, a view of the room or rooms that they're working with that is realistic, but where they don't have to hold up their device or whatever it is, have glasses on all the time when they're working with it. The big advantage is that people have seen is the ability that such technology should provide them in terms of seeing things that are simply not possible today. So they can experience, for example, knocking through the wall between the kitchen and the living room to create one big open space. This, of course, presents certain challenges in the development work and maybe not something that we're going to support early on. But given that a user is working with more than one room, such as a kitchen and a living room, then be able to combine the two and get an AR view where you can actually see from one room into the next if the wall was removed. So, having talked about one or two of the things from a user requirements and user perspective, I'm going to hand over to Nick now, who is going to talk about some of the challenges technically and the outlook for the coming work in the project.
Hello, my name is Nick Zioulis. I'm working as a research associate at the Center of Research and Technology Hellas, and I will present the challenges that the ATLANTIS project needs to address, accompanied by a quick outlook of our ongoing and future activities that will lead to the development of the ATLANTIS AI vision services. ATLANTIS is based on augmented reality technology, which aims at enhancing our real world with additional information layers. It can be deployed in various contexts, like for user guidance, training, gaming, or more generally to allow for natural free viewpoint visualization of digital content. Augmented reality, this technological core is simultaneous localization mapping, a technology that can now be easily deployed in our mobile phones using widespread frameworks developed by large corporations. The evolution of augmented reality presently revolves around persistence, meaning the capacity to lock and persistently embed digital content inside our everyday environments. As Werner already mentioned, in ATLANTIS, our goal is to use augmented reality as a medium, which will facilitate the communication of concepts between remote users and enable a new form of discussion around these virtual concepts blending with real scenes. And as Richard pointed out, with respect to the targeted audience, this has to happen seamlessly, to not burden users with unnecessary interactions. The goal, therefore, is to have users pick up their mobile device and just see the proposed concept instead of manually placing objects within the scenes, which is the way most interior design augmented reality applications work today. Finally, one of the most ambitious goals that ATLANTIS has set is to enable the replacement of real scene objects, an important trait that future interior design applications will require. To achieve these goals, we need to address a number of challenges, with the first one being metric scale scene understanding. So within ATLANTIS, we will address this by reconstructing the scene from a single panorama, which is an annual pose task. In these example images from Shutterstock, we illustrate the results of a room layout estimation AI service, which provides a sparse planar reconstruction of the scene. This 3D representation will alleviate authors and users alike from manually scaling objects, allowing them to naturally edit the scene in 3 dimensions, and additionally offer the much needed for our targeted domain, room measurements. We plan to move beyond such simplistic reconstructions and jointly estimate the scene's finer grained geometry as well. Another challenge that this will set to address is the integration of proposed layout recommendations, both for the authors and our end users. To achieve this, holistic scene parsing will be initially required before proceeding to generate these proposed modification or recommendations. The main challenge will be to address the input spherical domain, which requires specialized processing and introduces heavy distortions. This will allow for the generation of the entire scene's object and layout graph, an important step towards offering recommendations for refurnishing or renovation. The most important challenge that this will try to address is the diminishing of scenes, to allow for the replacement of real objects with digital counterparts. To manage this, ATLANTIS will rely on diminished reality technology. As augmented reality emplaces virtual content within scenes, it works wonderfully in empty rooms or when placing objects in empty space, as seen in this picture from Roomle. However, augmented reality cannot replace objects. Take this example here, where a chair is to be placed instead of this furniture. Only using augmented reality will result on the right view, where the digital element is unrealistically overlaid on top of the existing furniture. However, diminished reality can remove objects. And following up on our previous example, on the left we see the current furniture for removal, which is selected, and the results that are when the image is manipulated and diminished are on the right. In this way, diminished reality complements and enhances augmented reality, as it allows for high realism in replacement scenarios, as seen in these two side-by-side views, where on the left we have the example using only augmented reality, and on the right the result after first diminishing the scene before augmenting it. This concept can be materialized in different ways, with one possible direction being an image-to-image translation task that will map full rooms into empty rooms. Or with partial object removal, after having the user select which object to remove, which can be driven by a segmentation mask followed up by that regions in painting. But the difference here is that while in painting offers general plausibility, we need to go beyond and target realistic outputs that are coherent with the scene structure. Overall, ATLANTIS relies on generalized scene understanding, specifically using spherical panoramas, and aims at delivering next generation of augmented reality that will allow for the replacement of objects as well. You can follow us on Twitter to be notified of our upcoming results and progress, and we would be glad to answer any questions you might have now or offline.